Cool, so it's 10:30, so we can start. Okay, so next up we have Daniel. He's going to be talking about TinyGo and how to build toys with TinyGo and lots of hardware. So round of applause for him, please.
Hello, I'm Daniel Esteban, also known as Conejo, and I will talk today about building toys or games devices with TinyGo. I'm a maker. It's like I make things on my free time, usually involving electronics. And maybe you are asking, what is TinyGo? TinyGo is not a subset or a superset of Go. It's the same language. It's just a new compiler that targets a very, very small place. We released version 0.12 2 days ago. If you want to know more about TinyGo, you could check the link there. About the last year at FOSDEM also talk from Ron Evan. And now we are sponsored by Google. When I talk about small places, I talk about this kind of microcontroller. Like they are really small. Maybe you should see this, some of you, but it's like Arduino, BBC Microbit, some of the Adafruit, like Itsy Bitsy or Secret Playground Express. TinyGo also compiles your Go program to smartwatches, like the Pine Time. Just go to the AW building and check the Pine 64 booth stand they have there. We have support for several other devices, sensors, and actuators, like RGB LEDs, real-time clock, humidity, temperature sensor, sound, light sensor, distance, a lot of things. And also, a lot of displays. If you don't have any board or jet, or you don't have any devices to play, you could. We also have a playground. We simulate some of the board, and you could try TinyGo without installing anything on your computer. So, what are you going to see today? Well, some small toys, some fun-to-make projects that you could do at home. All the information is on the slide I will upload later. I will just go over the highlight or the main different part that you need, the very basic you need to make this project. So the first one is the gopher set. I don't know if you know this game is called Simon sometimes. Like it plays a different tone and lights a different color, and you need to match that color, and it will be going a longer sequence each time for the Simon, it's very simple. We'll only use 3 buttons and 3 LED and some printed part, and I will just use an Adafruit Playground Express, which is this little board. Our Go code, we start with the import. We just need to import the main package, the machine package, which is a special one to talk to the hardware. And we also are going to import like tinygo.org/x driver buzzer, which is to make sound. To set up the LED, we just define an LED like machine.A1 or A2 or maybe D12 because it's the pin number on your board. We configure it as an output pin here, And to enable the LED is as simple as LED.high or LED.low to disable it. For the 3 buttons, it's very similar also, but instead of output, we configure them as an input. And just to check the status of the button, is it pressed or not, yes, we do button.get, and it will return true, false. For the buzzer, which is a small speaker that makes sound, again, we define the buzzer pin. We configure it as an output, and then we create a buzzer device. And to play a song is as simple as just call the function tone with a note and a duration of that note. The rest of the code is your normal Go code. There is no difference there. And since it's a bit longer than I wanted to, I will not show, but it's already in the slide and in GitHub to check it. But you will check it's the same. It's the same as Go, and it's no difference. To flash it on your board so it's programmed, you usually just connect it to your computer, and normally it's you double press the reset button, so it's the board, in this case the Circuit Playground Express, enter the programmable state. And then it's I'm sorry. And I don't know how to change it now. I could make bigger. Yeah. So to flash it is just as simple as TinyGo flash. You specify your target, in this case the Circuit Play Express, and the code you are going to flash. We wait a little. And now, wait, it has a battery, so. And now we have our Go program here. It would play. And it will go longer and longer. It's for the next one, I don't know, probably you know the game called Pong. Sometimes it's a hockey game. We just need a display. This one is not so tiny. It's a little big. Actually, this is one like you could put several together and make those big billboards on the street or in the stadium. It's supported by TinyGo. And also for this case, I just add a real-time clock. So actually, the game is playing itself while showing the hour, and when it's time, one player or the other will lose. For the game, we just need 2 potentiometers. I use them as the knob here. They are analog input. We also use that huge LED matrix, and in this case, I choose an Arduino Nano 33 IoT, And as I said, real-time clock optional. Again, the import part is you just need to import the machine package, the driver for the Hub 75, which is the LED matrix, driver for the real-time clock, and the tiny phone package, which is a special package also that allows us to draw text on every TinyGo display supported. For the analog input, it's very similar as the button of the previous example. In this case, we need to initialize the analog to digital converter, but the same is we just choose a pin and configure it, and instead of true false, now we are getting an integer variable depending on the value of the analog. For the screen, also, quite simple. We define a serial peripheral interface, SPI interface, for the screen, and we create a Hub 75, which is the screen device. We make some configuration of the displays, but then we just call, like, we could change each pixel with set pixel, just the X, Y coordinates and the color. Again, you write the rest of the code, you put it in bootloader mode and flash it. And there you have it, here. For the real-time clock, again, instead of SPI interface, it's an I2C. We configure it, and we just use, like, you will see, I mean, you are seeing that this is normal Go code. For a third project, we could make a portable game console. You have some option. This is all, we are also using this as a badge. Wait. But yeah, it's a little blurry. Sorry. Okay. Yeah, I put the GIF there because it's better. You have several options here. You could make a homemade one with a spare part you have, or you could buy there are some board like this. This is a Pi badge, but there are also pay gamma or each badge. Like more or less, as long as it has a display and some buttons, you could make your own games. Of course, if you want something more professional looking, you could use a Game Boy Advance. Because actually, it's right. We just compile a Go code, and it's running on a Game Boy Advance. I cannot tell you exactly how you should put your binary files there. Maybe it's not really legal, but and for your games, you could use TinyDraw. It's a package to make simple primitive on every screen that it's supported by TinyGo right now. We also have TinyPhone. which is to write text on the displays also. The last two projects I like a lot. They are community projects. They are also open source and open hardware. The first one is called Scornabot, which means Beatles. And it's an educational robot similar to a Bebot or a Cubeto, and it's great. And I mean, it's being used in a school right now to introduce young children into programming. Children are not programming the robot itself, but they are just using the top buttons here to make the robot move or turn. It doesn't that much. Just the children click the button, like move forward one step or two steps, then turn right, then go backward. As I said, it's being used in a school. If it's not the Scornabot, it's usually the Bebot or Cubeto. They have several different activities with them. For the robot, the most important is like you just need 2-stepper motor, 5 buttons, 1 buzzer to make sound, which is optional, some 3D printed part, and a microcontroller. We already see how to use the button, and the only addition to this project is the use of 2 motors with the easy stepper driver. In this case, if you have 1 motor, it's just create a new easy stepper device. You just configure and just tell the motor to move 200 steps. But we have 2, so instead we use easy stepper new dual device and just tell them move. Again, we flash the code and see in action. In this case, it's a little gopher. So we just tell them to go forward, turn right, and then come back, and it's moving. The last project is possibly my favorite. It's called Open LED Race. It's also a community project. It's open source and open hardware. You just create a racetrack with an LED strip, and then make the different LED move. You simulate a race with any input. For this, you need an addressable LED strip, anything as an input, and just a microcontroller. The only difference here is the WS2812, which is the LED strip. Just select the pin for the output, create a new device, and you just write the color you want to appear on the LED strip. I will need 2 volunteers that want to compete in the game and just win some hardware we have to give away. So if you know how to click a button, please raise your hand. Just check, both of you. Okay. again, since it's an open hardware project and community-driven, I said you could use anything as an input. So people is doing different kind of thing. We just simulate the track. In this case, on the left picture, we could simulate the gravity. So we are creating a virtual slope that will slow your car and on one side and speed it up on the other. Yeah, I know. Also, in this case, Arduino Nano has a Wi-Fi chip, so why not add Wi-Fi to your project and have telemetry data like the professional? And if the Wi-Fi works, yeah. Okay, maybe. You are going to be the red gopher, you are going to be the... Wait. Okay, there you go. Wait a moment. Yes. Okay, it's too much. Yeah. Wait. I don't know if the Wi-Fi is working, but we'll see. Yes. Oh, it's not working, but press the button. Yes. Oh, what? And for both of you, this an Arduino Nano is compatible and you could make this. So, as I said, everything is here. Okay. Everything is here. All the projects you see are working and are on GitHub right now. And if you just like, join us at TinyGo channel of Slack. And thank you.